So I can't promise such a high-reaching talk. This is going to be a little bit more self-indulgent, mainly about what we're doing at Hoxton. And on the theme of self-indulgence, I thought I'd kick off about me. So 6 quick infographics of how I ended up chemistry student about 10 years ago to CTO of an analytics company now. So left uni, went into strategy consultancy, didn't really know what else I should do. So spent 3 years getting really very good at Excel. Could do some things I was quite pleased of then in Excel and now seem trivial. Moved on from there, worked for Coca-Cola in analytics, so in a digital team for them. Worked for there for a couple of years before I started to realise that Coca-Cola wasn't the place to be world leading in analytics. Getting really into starting to manage sort of big data products and realise that trend is the way it's going. So went back to UCL, studied machine learning and big data. Met my co-founder Owen, who had this crazy idea that we'll go into in a bit. Didn't join him at that point, went and worked as freelance somewhere between data science and consultancy for a while. The reason for the car crash is that what I studied particularly or did a lot of work into was telematics insurance. So I was basically predicting car crashes and helping insurers price accordingly. Worked on that and a number of other projects for a year or so before Owen persuaded me to come back. Just getting some traction with investors, come and join Hoxton Analytics, which is where I've been for the last couple of years. So today I just wanted to go through 4 main things. We're an Instore analytics company, so I just wanted to talk about that for a bit, set the scene, why it's important what we're doing, then talk about what we're actually doing and why we're a bit unique and a bit quirky. Go through what we do for our clients and the value of that, and then finally, because it's an applied AI session, talk about some of the learnings I've got, and in particular the differences between the sort of armchair stuff, the student stuff I learned as a student, and the realities of actually trying to do it in a real world situation. So firstly, Instore Analytics. So all very, very familiar with internet analytics, page visits, click-throughs, conversion rates, all that stuff, been around for ages. Google Analytics, massive, massive business. Whereas Instore Analytics was just all about sales. For years, it's just sales, that's all they really care about. At a basic level, some retailers have been doing footfall, but there's the same metrics if you think about it. It's exactly the same. How many people are coming in? Of the people coming in, where are they going in the store? What are they buying? What sorts of people are these people? All this information you should be gathering, analysing, and optimising your store as a result of. But they weren't doing it. They weren't doing it because they didn't really realise they could, and because it's that bit more difficult. But over the last 5 to 10 years, they've realised that the only way to compete with online is to do analytics. So as a result of this, there is now a whole host of different techs for doing in-store analytics. So right from infrared beams, which is just like a laser counter at the door. You can use camera surveillance tech to sort of find where people are going, either blob tracking or look at people's faces using facial profiling. You can track people's mobile phones. All this sort of stuff now exists. It's incredibly fragmented, and no one solution is really taking over. Also Bluetooth, which is now dying out, mainly because we heard about one Bluetooth company in particular that were telling a retailer that their sales were declining incredibly fast. Actually, what was happening is Bluetooth was being less and less used incredibly fast, and their sales were absolutely fine. But that's a bit of a digression. Anyway, here's the scary bit. So there's a problem. So there's so much desire in in-store analytics at the moment for more insight, online levels of insight, that some of those techs are beginning to infringe on what consumers are comfortable with. And this is some of the stuff that people are saying. Customers hate in-store tracking. 3/4 of shoppers think facial recognition is creepy in those instances. So this is where stuff like Wi-Fi tracking, where you've got a personal identifier on your phone, stuff like looking at your face, where a personal identifier has been taken without you, okaying that. And so this is where the boundaries are being pushed at the moment. So we took a bit of a different approach, and my co-founder who came up with this original idea was thinking, most of the information that is being collected is generic information. They don't actually want to know who you are. They just want to know what they can about you. What sort of shopper are you? Where are you going? Where do you go in the store? And then what do you buy? And how do you link it through? So how can you start to do that, get that summary information without going via the creepy bit that people aren't comfortable with? And that's essentially the problem that we think we've solved, and results in headlines like that. So here's the cool bit. How do we actually do that? So as I said, I met him at an AI masters. So unsurprisingly, the answer sits in AI. But he had this idea that, okay, you look at faces. Faces are personal, but why not look at the rest of the body? So clothes. Clothes are impersonal, but you can tell very easily quite a lot about someone from their clothes. Quickly realised that actually looking at clothes is quite creepy as well. You can't really just point cameras at people's bodies. That's a bit weird. But then he thought about shoes. And actually, you can equally tell a lot of things about people from their shoes, but people don't really care about shoes. It's not viewed as something that's as personal. So that's what we did. We developed a system that is essentially extracting insight from shoes. And if the video works, this is the first stage of it working. So this is a shopping centre from our device, which is just a camera and a computer processor on site, which just looks across a doorway, so completely anonymized information, looks across there, and then as people come past, it starts to identify the shoes. We then have to talk a bit more about what's actually going on in the algorithm, but essentially we sort of then have to link those observations and then conclude whatever else we can about it. But that's a sort of visual that helps you at least start to understand what's going on. So what have we actually invented? Well, it's basically it's a next generation of people counting. We are at a basic level we're counting people. It's a little unit. It's incredibly easy for us to install, unlike a lot of our competitors. It's very accurate. I'll talk about accuracy again a bit later. We can profile customers to a degree. I'll talk about how much we can now and maybe in the future about that as well, without any privacy issues, as I mentioned. And one of the things we're really aiming for on this is that it's very cheap, it's very easy to install. So the price point where before our competitors would just stick one over the door, we can stick them all over a location and get much more in-depth information about where people are going, where they're dwelling, and all that sort of stuff. So I just wanted to go into the algorithm a bit. Partly because I think it's quite interesting, and partly because we are hiring, and I'm very interested in getting some experts. So I thought if I go into a bit more about what we're doing now and what we're doing in the future, maybe I can convince some of you guys that this is the problem to work on. So it's very, there's many things going on. Firstly, we've got it's a basic image recognition problem. So where are the shoes in an image? In a stream, and it's very particular to us. So it's on that sort of image that you saw. Where are the shoes coming in? Once we've identified those shoes, we need to come up with a unique people count. So we need to build a model that's going to link all those together, link the ones that belong to the same people on one step to the other step, and not get someone else confused in there. Once we've got all that sort of information, so that's Analytics 101. We're then reporting in real time, how many people are coming in. We can also link in and out observations to get stuff like occupancy and dwell times and things like that, which is interesting information for our retailers. And then the second step, when it gets really interesting, is then when we take those images associated with someone and start to work out what we can tell about them. So we can do gender classification at the moment. We can also group people into styles. And by styles, I was also sort of thinking sort of mission type, so we can tell from trainers if it's a shopping mall that has a gym in it. At certain times they're probably more likely going to the gym. We can tell, smart casual men's shoes, women's shoes. There's obviously some shoes that are sort of more gender agnostic, but you can actually tell quite a lot about someone based on those shoes. We can also do groups based on the observations that we've made. We can tell whether people are in a family. Have you got a man, a woman, and a child together? Are they in a couple? All that sort of stuff. So that's where we're at, sort of at the moment. All, as I said before, just completely anonymized information. what I think we might be able to do. So the cool stuff, we're starting to investigate how we can track individual shoes around buildings, such that, I see an observation in a particular camera, can I see it in another camera? Do I then know what actual people flows around those buildings are? Starting to do visual search, so take those images of shoes, can I actually work out what shoe that is? Can I do brand recognition? Is it a particular Nike shoe, for instance? Do I know how much that retails at? Is that interesting then? Can I make certain conclusions about that person? This one is my personal favorite, which is where we start to do clustering based on people's actual behaviors, because we can start to link, if we link up with a till purchase, so place another camera at till, I know what people have bought, and I can suddenly link types of shoes with purchase behavior, which is very interesting for the retailers. Certainly if I can predict when people are coming in at the doorway, whether they're a likely purchaser of certain things, what they should market to them, I then get a feedback loop later of, however long it takes them to buy stuff, telling me whether I was correct or not, what have they bought. So that's a very interesting problem. And then the last one, who knows? So I don't know how far actually we can push this in terms of what we can learn about people's shoes. But for those who are interested, there's a interesting, well, depending on your interest, but a study done by Kansas University looking at what humans can conclude about other humans based on a series of shoes. And they showed, unsurprisingly, very strong correlation on gender, very good at gender, pretty good at income, so again, not surprising, quite good at age, which I think is surprising. And then weaker correlations, but still statistically significant correlations with politics, with attachment anxiety and agreeableness, among other things. So all entirely from shoes. So I'm not sure how commercial of value those things are, but the point is, I'm not entirely sure as of yet how far we can push this, but we can certainly push it a lot further. Just wanted to quickly touch on accuracy. So we're currently 95% accurate on footfall as a minimum. That's what we'd guarantee to our clients, which is market leading. And we're 80% accurate on gender at the moment in the real world, which interestingly is just as accurate as facial recognition when in the real world. So, does it actually work? Yeah, it does. And works probably better than we thought initially when we were testing as to whether this was a good idea or not. Just going to go very quickly through the next couple of slides, but they're just wanted to sort of highlight the traction, the journey we're on at the moment. So we've got plenty of traction in the press, and we're also got a number of good sponsorships for us. So we're aligned with Cisco and Tata, among the bottom two are sort of investors. But very important for us as we see ourselves as a sort of software play, and I find hardware a bit of a nightmare personally. So we have a strong link up with Cisco, who are providing a lot of our hardware and helping us with that sort of stuff going forward. So just wanted to spend a bit of time giving examples of why is this information useful? What sort of clients do we work with? I'm going to go through three use cases fairly quickly. Firstly, a shopping centre. So these guys are absolutely perfect for us. This was our first paying client. We installed our device in their shopping centre for 5 months for free, alongside a previous device that they had. It took us that long to prove that ours was more accurate. They could also get a load of information out of it. We put more devices in, and it would be cheaper. And at that point, we managed to get them. But for them, footfall is everything. So they don't have sales from their clients. Everything is all about how many people we're dragging in, who's dragging them in, which tenant is an anchor tenant, which tenant as in bringing in extra footfall, and which tenant is just converting footfall that exists. And therefore, how much should I charge the rent to the different people? What is my demographic breakdown? Therefore, which sort of tenants should I have? All that sort of information. So we were able to provide them that in real time. So their footfall, as I said, they were getting footfall before. We were able to demonstrate that ours was more accurate. And then we've started to show them the extra stuff we can do on top, and they've been delighted. Then we had some work with an airport club lounge. So this is, I was alluding to before, we can do occupancy. So these guys were very interested in knowing how many people were in their lounge at any one given time, and that was something they just couldn't track any other way. And because it's a very difficult problem to do occupancy, you might not think it is, but because errors persist, if you want to know how many people are in the building, if you're counting both ways, if you've got some error with that, then it's going to persist all day until you can zero it again in the evening. So you need quite an accurate system to be able to do that, and most systems out there aren't accurate enough. And we were able to set something up for them that showed them real-time occupancy. They'd check it during the day, check that they were happy with it, and we were able to demonstrate that that was something that we could do to a level they were happy with. And then we also gave them some gender split and some group split as well down there, so they could tell not just how many people are using it, but what types of people tend to use it at what different times. Finally, a supermarket. I'm going to fly through this one. But supermarkets have been challenging for us because normally what you get from them, or particularly Tesco, is, well, we've got loyalty card data. What can you tell Tesco that they don't know? They don't know about their shoppers, right? But again, this answer of if you start to put these devices all over the shop, you know roughly where people are going. So Tesco's know who's come in and what have they bought. They don't know where people in there have gone, what percentage of people are converting. So if they look at two Tesco stores and one is selling a whole load of wine and one isn't, they don't know whether that's just because their customer base is different in the two and they just have a lot more, families maybe that are going to buy more wine, or whether it's because people just aren't finding the wine aisle, or whether, is it something that they should be worried about, or is it not? And you can't do that until you have this sort of level of information of people flows and KPIs by that sort of information. And here's an example of that sort of stuff. Cool. So finally, that's enough. It's enough on Hoxton specifically. So I thought I'd just cover, last few minutes, just cover a few learnings that I've had as a result of the stuff I've done. The last 4 years or so, from being a student and learning this stuff out the first time to now having built a system that's working, mostly working, out there in the wild, and that's actually a genuine product. So this, I'm sure most of you are familiar with the Boston house pricing problem, which is one that I seem to be taught a lot. I don't know if the rest of you were. It was a lovely problem, very well contained, had lovely training data, all with the perfect features already produced that you needed, lovely outcome you're predicting, which is house price, which you would nicely learn again when someone bought the house. So there you go, you got the feedback loop, perfect problem. You can just basically play in this little area of, here are my features, which I know are good, and here's my outcome, and I'll just test different algorithms and how all the little settings of the algorithms, and never sort of move beyond that. And then I went via, I suppose, the intermediary step was what I did as a freelance consultant, which is a bit more of, we've roughly got the training data. This is, we've got a fairly well-defined problem. We've got a fairly well-defined evaluation metric. We've got some data. It's probably not quite right, so you're going to have to play around with a bit of feature engineering, and then you're going to have to play around with the algorithm. To what my co-founder challenged me with, which is, I think we can get some information from shoes. And there's no data set there, there's nothing. And for a bit of fun, I drew this up first as to reckoning where I spent my time as a student and where I spend my time, or my team spends its time now. And basically, I never considered that I'd have to build my own training set. And now probably the single most valuable thing we have as a business is the training set to these algorithms. No one else has this. They're not publicly available. They're an absolute pain to create. But good luck if you want to create 30,000 well-labeled shoes. Good luck. It takes a while. So yeah, that's the sort of thing. And then the second point in that is, and I'm going to touch on both of these in a bit more detail, but the feature engineering point is the other one that you realize more and more how much of the clever stuff is due to that. So yeah, training data. So here's a few shoes that I just stuck as a nice little collage. Every step that I touched on before has its own unique unique training set that I need. So that initial image recognition step, great. I need thousands and thousands of photos of shoes, and I need thousands and thousands of photos of non-shoes. More importantly, though, as we realize, you don't want them, you can't just get loads of shoes. That's not helpful. I need it in the context that my devices are going to be in. So the only real way to do that is just to video it and label it. And we've learned lots of cleverer ways of doing it, and there's lots of actually quite clever techniques that I'm not going to go into, that you can start to do this and speed it up. But it's certainly not the thing that I'd traditionally think of as the sort of expertise in this area. But a few things I did learn. We made some quite big mistakes early on, so I think if you are going to do something like this, you have to do it in small steps. You have to do a bit, build up a training set. You have to then see if it's working and push it all the way through to the result you're trying to predict and try and measure that. Like if you start doing big steps on this, you'll just get to some horrible stages where you realize you have to redo the whole thing, and that's not fun. But yeah, so not only this, so this is, if you think about this as one problem with the labeled one, another problem is, well, how do you get a data set if you're trying to predict people's gender based on their shoes? How do you get a data set if you're trying to predict people's group size or any of this stuff based on their shoes? So these were the sort of probably the biggest problems that we actually overcame. And as I said, I'm not going to go into too much detail because I think it is quite important. The other one is feature engineering, which I remember being told by the first time I got into realizing it was important was when I did my thesis. And my supervisor just told me it was a bit of a black art. And I agree with him, but I think I still find it amazing that more of the stuff isn't sort of documented and more techniques. You know, every time you read a paper, they focus a lot on the different algorithm they use and probably less so on why they chose the features that they chose. And often the paper will start at, we're using these features. You know, why on earth are you using those features? So that I always find quite frustrating, but I'd certainly say what's one of the skill sets I probably value the most now is the ability for people to pick out quite quickly, you know, what are the features, what the problem I'm doing, what's the information going to be valuable, and how do I generate that? And so just using a couple of examples here, so shoe size and gender, this is at the far right. So you can see that's an incredibly good feature. It's almost perfect. If you just use shoe size, if you know shoe size accurately of someone, then you know their gender to just under 90% accuracy. Market leading is 80%. So if you can do that, you're there. Now, getting accurate shoe size from a 2D image is not that trivial. But if you can do that, and we're pretty close, then you know it doesn't matter how good your deep neural net or all the rest of it, it's not going to come close to just getting that feature correct. The other one is a sort of open problem we're working on when we're starting to compare two different shoes. So this is the same shoe taken by our detectors about 10 meters apart by two different detectors. It's exactly the same, it's just in different lighting conditions. You can't even see the one on the right because it's so dark. But this is, you know, it's very, very hard to get something, with those two images as is, you're going to find that almost impossible to get an algorithm trained to work out that those are the same thing. If you can do some clever color constancy type work, then you can get some two things that look pretty good. Final thing I'll say was when we started showing a lot of this stuff to our clients, you know, and the insight we were generating, if it surprised them, we basically had to prove ourselves. If it surprised them in a bad way, we really had to prove ourselves. So we told one client, we basically said their footfall had gone down, and even though their previous provider didn't give them any accuracy, there was no sense of what the accuracy on their previous numbers were, just because they went down, and down's bad. We suddenly were under all sorts of scrutiny of saying, well, are you sure it's accurate? Yeah, you said it was accurate there, but how do you know it's accurate? So we came up with this way, as a direct result of that, was like, well, how do we know it's accurate? How can we test it? And we realized that because of that video footage I showed you earlier, we have a very good way of getting a human just to verify it. So now we send a chunk, not too much, but you know, almost a percentage point for people who are interested of that information to someone to manually count so that we continuously have a view on our accuracy. And we actually report to our clients, we tell them every week how accurate we were on the people count. So it's still there, it can be a pain, but it can also be a competitive advantage. No one else in the industry does that. And we've got a couple of people interested directly off the back of that. And now we're trying to work out how we can do that with the other sort of products that we offer. And yeah. that's it. So I'd just like to reiterate that, yeah, we are hiring, we are interested in, particularly people with a leaning to computer vision and that sort of stuff. So do get in touch to the Will at Hoxton Analytics, and yeah, questions.
Actually, let me go first. I got a question. So how did you collect the initial training set of data? Like, how did you collect the data initially?
So the early stuff was, the very early stuff was Owen sat in coffee shops with a IP camera below. Yeah, but that's weird. Ignore that now. No. I think it's still the same. It's the same it's the same idea. And interestingly, so I'm going to digress slightly. But because of the privacy stuff, because of the types of information we are collecting, it's absolutely fine to do it in public places. So we can do something we offer for our retailers is that you can point the camera not only in store into the private area, but you can also point it out into the street and gather the information of people in the street because you're not collecting private information. So essentially, yeah, he did that. He went around, gathered from a variety of locations, labeled it, and then built it up from there.
I have a bunch of questions.
Oh, sorry, I think this. Okay.
What do my shoes say about me? I'm not sure if you get asked that a lot. I don't know. And the second one is, so do you identify the position of your sensors and use that maybe by gait analysis or something like that to identify this shoe is the same? So my sensor is 10 meters apart. I know he walks at this speed, and therefore it's the same shoe. It's just a question. Or something like that.
Yeah. So just to repeat the questions. Firstly, what do your shoes say about you? So yeah, no, it is a question. Obviously, we get quite a lot. But I mean, you can say, so given the size and style, I think they quite obviously male. But you're in luck.
80%.
You're in luck. Yeah. But it's all a relation of how the algorithm processes this thing, based on frankly millions of images that it's seen, and it's distinctly better than me. I quantify it, so I'm going to dodge that, how I'd normally dodge it, and that we'll have to ask it. And the second question was basically, do we use gait analysis?
Like you've got 10 sensors, and you know a person's walking at speed from one sensor,
yeah,
and your colours change, but you might know because of position that it could be the same person.
Yeah, so what we do and are starting to do is follow people or shoe observation based on sort of a statistical model of, given one leaves here then, and we see one there then, of this sort of type, is likely to be the same person and attracts like that. What we don't do is, because we don't see enough of people to do proper gait analysis, so what we don't have is a unique footprint or ID of that person, so we can't say this person's come back a week later and draw up a picture of them. We can just say, based on those observations, and yeah, as you say, it's better if you have lots of ones around, I can build up a map of where people are going, but not so far as to start to identify people and track them around. I think the man here.
You mentioned that using shoes overcomes the whole privacy issue that you would have with facial recognition or other similar methods.
Yeah.
However, we all remember the news item from maybe 18 months ago when the president of France, François Hollande, was caught out in his affair that he had, even though he used a motorbike helmet to visit his lover whenever I was going to visit her, and used different motorbikes on different occasions. He was still cut out by his shoes, by wearing the same shoes all the time. So I'm not sure that the privacy claim that stands out. Also, do you intend to work with, or do you currently work with people who deal with large crowd dynamics, so football stadiums, places that hold music gigs, and that attract thousands of people, or other settings in which there's very large crowds that may move about at, not quite slowly, but at speed?
Okay, so two quite different questions. I think firstly, can you argue that genuinely, I think the question is basically, can we argue it genuinely is anonymous? And is the privacy point genuine? Because you can perhaps imagine scenarios when coupled with other information that this does become invasive or de-anonymized. And yeah, no, I think that is a difficulty. I'd say certainly we are well to the right side of all the other technologies where you can identify everybody without doubt. So from a mobile phone signal, you just have to see who it is, and then you've got a mobile phone signal that you can track. From a face, it's exactly the same. And the problems with those, particularly faces, is that you have no option to change that. A mobile phone a lot harder. So I think, yeah, there would be, perhaps you can come up with creative ways in which observation of a shoe in a certain place at a certain time, you can work out who that person is. But yeah, it is almost certainly a lot harder, and that person, in my view, always has the ability not to wear that shoe, which may or may not be a good argument. But there you go. And the second point was crowds. Yeah, so there was, if you think about the video you saw, so that was quite busy then, and it captures everyone. So as long as you see a shoe, it'll capture it. You can imagine a situation where if you can't see shoes, then it's not going to capture it. If it's so busy, people are shuffling through so much that you can't see the shoes, then it's going to start to struggle. So far, in all the locations we've been, and we're in the Natural History Museum, which gets pretty busy, we've not yet witnessed a point at which the accuracy significantly starts to fall off. And as we're monitoring constantly, as I said, then we do have a very neat plot against of sort of traffic versus accuracy. And so we haven't seen that. But yeah, you can certainly imagine a scenario where if it is genuinely completely rammed, that it would start to struggle. But then I don't know a single technology that wouldn't.
So, time for two really quick questions or one long question.
The hardware, is it specific to your use, or can it be used with any type of camera?
So we have two approaches to market. We have a piece of hardware, which is that's actually mostly off-the-shelf components at the moment that we've developed ourselves, but essentially it's a camera and a processor and a means of communication, so sort of bits of the mobile phone, really. And we also go via Cisco, and Cisco would use their own hardware, so they would just install one of their own cameras, we'd run it on their servers, and there's no real reason we couldn't do that with anyone and any camera, as long as we got somewhere to process it.
And the girl at the back.
Yeah, just wanted to ask a question about something that might not be your problem, exactly, but I would imagine that the retailers that this is most valuable for are those that have, where the majority of their customers are through store rather than online. And I'm thinking about an example like a DIY store or something like that. I would think that this kind of information is hugely valuable, but it's probably going to blow their minds a little bit, particularly about things like how many people walk into a DIY store and actually convert into a purchase or don't, and what dental are and all that kind of thing. Do you get asked to help with so what on earth do I do with this, or does that kind of go into the black hole?
Not yet. So I'd say where I started with who I thought our customers would be, and who we were most excited by, was this greenfield opportunity where there's loads and loads of stores that don't have any analytics. What we've realized quite quickly is that they're going to be hard to convince because they don't see the value in it. And so it's a much harder sell. You've got to come to them and say, this is why you need this information. This is what it's going to do for you. And it's a much harder sell. Where we've had a lot more traction is people who already had analytics, but had a solution that we view ours as slightly better than. So we can essentially do what they're already doing, which is normally things like footfall. And we say, look, more accurate, and we'll do it for the same price. We'll give you a load of other stuff as well. So that's more, I think those sort of people, if they don't have anything, it is quite, as you say, it is quite a difficult sell to sort of convince them that they need it. So at the moment we haven't really focused on people like that, and are more going for people who already have, a person in Instore Analytics, someone employed whose job it is to buy this stuff and to maintain it. At some point we'll have to come up with a strategy to how do you get in and prove to these people that this stuff works.
Cool. Grant will at the end.
Yeah, no, I'll be hanging around after for a bit. So yeah, do
Thanks
come and ask
very
some
much.
questions.